Trigonometry is the field of mathematics that studies triangles, and our fascination with triangles can be traced all the way back to the ancient Greeks. And we know that Pythagoras developed the Pythagorean theorem that only dealt with right triangles. And what he discovered is if we were given the lengths of two sides of a right triangle, we could calculate the length of the third side by using his theorem, a squared plus b squared equals c squared. That works beautifully as long as we have two side lengths. But sometimes when we have our right triangles, we are given one angle and one side length. If that's the case, the Pythagorean theorem doesn't work anymore, so we have to use something else. And what we use is what is called the trigonometric ratios. Whew, that's a mouthful. So those three ratios are the sine, cosine, and tangent ratios. And a way that we always remember it is SOHCAHTOA. And you can go on YouTube and there's videos about SOHCAHTOA. They've made songs about SOHCAHTOA because it really is the way people remember these ratios. Now, what does it mean? Well, the SO stands for sine because the sine's ratio is the opposite side length compared to the hypotenuse side length. Cosine is the adjacent side length compared to the hypotenuse side length. That's the CA. And the TOA is the tangent, which is the opposite compared to the adjacent. Now, these are ratios, so they're a comparison of two sides. So if we think about a right triangle, and sine, cosine, and tangent can only be used with right triangles, we know that directly across from that right angle, that's our hypotenuse. Now, our adjacent and our opposite, we can only determine based off the angle, because remember, we use sine, cosine, and tangent when we're given one angle and one side length. Well, if my angle is A, directly opposite A will be the opposite side. Touching A is the adjacent. So adjacent has to touch the angle. Opposite has to be opposite the angle. Now, it's all based from the viewpoint of the angle. So if we come over here and we take a look at this right triangle, because it's only going to be with right triangles, I see my right angle. I know that's got to be my hypotenuse, so I got to look for my angle. Well, here is my angle measurement. There are no other angle measurements given. So when I look at my angle, whatever touches it is my adjacent, sits side by side. That's what adjacent means, side by side. And whatever is directly opposite is my opposite. So from the viewpoint of this right triangle, the only information given to me is my opposite, my hypotenuse, and my adjacent, but I only want to look at tangent. So if I go back to what tangent is, that's that TOA. Tangent is opposite over adjacent. So if I want to find the tangent of angle A, my opposite would be 7, my adjacent would be 24. And it is a ratio, and we can leave it in a ratio format. If I take a look at this right triangle, and I want to find angle A, the tangent, well, from the viewpoint of angle A, my opposite would be 40. My adjacent is what touches it, which is 42. Now notice the hypotenuse also touches it, but the hypotenuse is always the one that's directly across from the right angle. So we never take the hypotenuse as an adjacent. So if I go and do my ratio of my opposite compared to my adjacent, now we have to follow rules of ratios. So we have to reduce it to lowest terms. So I could divide both of these by 2 and my ratio would be 20 compared to 21. Now some of you are thinking, well, how does that help us find side length? Well, when we're really looking at side length, we have to develop an equation for it. So we're about to get to that. I just want you to think about what the ratios would be. Now, I could use the same triangle and I could develop my tangent ratio for angle B, because it's always from the point of view of the angle. So if I take a look at tangent of angle B, my opposite would be 42, my adjacent would be 40. When we go and reduce those to lowest terms, take a notice here, they're just flipped, they're reversed. So whenever you're deciding whether to use tangent, think of it from the viewpoint of the angle that you're looking at. So now let's actually get an angle. So here I have this right triangle. I've been given an angle of 52 degrees and I've been given one side length. of 24. Right there, I think SOHCAHTOA, because if I'm given one angle and one side length, my Pythagorean theorem doesn't work. So from the viewpoint of the angle, I think what is given? Well, I have an opposite and I have an adjacent. And instantly, if I have opposite and adjacent, I have to go to that TOA, which is my tangent ratio. So then I develop it. Well, from the viewpoint of the angle, I say tangent of 52 degrees. Now, what is my opposite? My opposite is x, and my adjacent is 24. Well, we'd be stuck right there unless we have a calculator or we have what's called the trigonometric ratio sheets. And those can be found in any math book. But for every degree measurement between 1 degree and 89 degrees, they have calculated in decimal form what that degree measurement is. So you have to access that. Now, for us, if we don't have a calculator, you have to go look up those ratios. And it's just a huge ratio sheet. And it has sine, cosine, and tangent on it, so you can find all of them. So when I look up on my ratio sheet and I go to 52 degrees and I go across a tangent, it gives me this decimal number. And I replace that tangent of 52 degrees with that decimal number. Then I've got an equation. And the moment I have an equation, I can solve for x, which is going to be my side length measurement. So in order to get x by itself, I have to get rid of this divide by 24. So I'm going to multiply by its multiplicative inverse on each side. So I'm going to multiply by 24. Now when I take 24 times 1 and 2,796 10,000ths, I get this decimal 30 and 7,104 10,000ths. Okay, usually they ask you to round it to the nearest 10th place. That's frequently what it is. So if I round this, I get 30 and 7/10. So what does that mean? Well, it means this side length is 24, this side length is 30 and 7/10. So you can figure out the side length measurements through tangent, through sine, and through cosine by using these trigonometric ratios. That's the focus. Now today, we're only working with tangent. So everything we're going to do today is about the opposite compared to the adjacent. Tomorrow, we'll get into the next two ratios. Have some fun figuring out these side lengths. Good luck.